In this video, I focus on understanding user interests and recommending posts. I wanted to track how much time a user spends reading or viewing a post to understand their interests. Using the existing polling system for posts, I increment a view count each time a user stays on a post. This way, longer engagement increases the weight of that post. I also explored text embeddings for the post content. After comparing OpenAI and Google, I chose Google GenAI and tested it with a simple Python script that generates embeddings when the server starts. Next, I installed Pgvector in Postgres to store embeddings and index them for similarity searches. I used an IVF flat index for faster lookups and settled on a 1536 dimensional embedding. After discovering higher dimensions were not supported by the index, there were a few setup issues: migrating from integer to UUID primary keys, missing Postgres extensions, and building Pgvector from source because my Postgres installation wasn't compatible with Homebrew. After fixing these, migrations ran successfully and the embeddings were saved in the database. I initially considered using a weighted average of post views to determine user interest, but that would flatten multiple interests. Instead, I built a user cluster model where each cluster stores a centroid embedding representing a user's interest in a topic. When a user interacts with a post, the system compares the post's embedding to the centroids of the user's existing clusters. If the post is close enough to an existing cluster, it is added there, and the centroid is updated using incremental averaging. The system calculates the new centroid based on the existing average and the number of posts in the cluster without having to sum all embeddings from scratch. If the post is too far from all existing centroids, a new cluster is created to represent this new interest. Different interactions influence clusters differently. Sending a post to chat counts the most, followed by saving a post, commenting, replying, liking a post, liking a comment, and finally just viewing a post. These weights are configured in Django settings and determine how strongly each action affects the user's interest clusters. Since we have the count variable in the user's interest, we know how many posts are there and how strong the interest is for that cluster, so it can identify a user's top interests. I fetch a variable number of posts per interest, more posts for higher interest clusters, fewer for lower interest ones, to generate a feed of recommended posts. Previously recommended posts are stored in the database and ordered lower rather than excluded completely, so users still see older posts once new ones run out. I also added a cosine similarity threshold, so only posts close enough to the user's interests are recommended. I created a signal that generates an embedding whenever a new post is created. Each interaction, likes, comments, replies, saves, sending posts to a chat, and post views also triggers signals that update the user's cluster with the configured weight. For post views, I only consider them for recommendations if a user has spent more than 10 seconds on a post. This prevents short accidental views from skewing interest. To make interests traceable, each cluster tracks its member posts. Interactions increase the weight of a post in the cluster. For example, commenting on a post adds more weight than just viewing it, reflecting the user's deeper engagement. The recommendation endpoint only returns posts that user hasn't already seen on their feed, keeping the experience fresh. I initially tried to make the number of times a post was recommended reduce its weight in a logarithmic way, but that became too complicated. Instead, I kept it simple. Posts that have already been recommended are still shown, but they are placed at the bottom of the feed. We don't use traditional pagination here. Each time the user loads more recommendation, the same endpoint is called again, returning new posts while avoiding duplicates. I realized recommendations aren't meaningful if there are too few posts. I added an endpoint that counts all posts in the system and only enables recommendations when there are more than 1000 posts. Otherwise, users see the normal feed, ensuring recommendations remain valuable and diverse.